Hello, let me continue again where I had paused in the last lecture. As I said, in the whole series, a part of it was about how to conceive a product. That's where that little creative and all that stuff is there. Then something was more related to the actual packaging, saying how do you select materials, or more than how do you select materials, how many materials are around normally used, and little about the interconnections, and also about the how to a little about a little bit of wiring and harness and connectors and so on. And then eventually now we come to how to actually make the drawings, because once you have the concept in your mind, it is very clear to you, at least the outline is clear to you, and eventually it will get transferred into a product. So what starts as a nebulous thing has to come down to actual physical drawings which can be taken to the fabrication shop. At this point, the last lecture I had stressed on saying how the concept of computer aided drafting started. It went on to computer aided design and detailing. Eventually it has come down to 3 dimensions. Even today, for a long time in the workshop, my colleagues have corrected me, instead of calling it a workshop, I should say in the fabrication facilities, drawings are read and they are coded by conventions. So if you have to see your own house, what the architect or what the civil people give, it will not be a 3-dimensional drawing of all the pipes, rods and all that. It will be designations which are very specific to that particular trade. In our case, we are concentrating on how to make a small equipment, usually meant for early serious hobbies or beginners who have joined the product design exercise. And eventually it will move on into one extreme is where the military takes care. Military has enough resources. And then we also have aerospace, which I will say sort of dovetailed. Where the resources are good and reliable and all that, still commercial accountability is there. Space is something else. Space, there is nothing like repair. You launch and hope. Unlike that, in the case of our serious professional equipment, we need to make something which is reliable and eventually producible and maintainable over a long time. And latest is how do you recycle it, and then life cycle management. From the product management point of view, it is not about built-in obsolescence, it is about how to extend the life of the product. So at one extreme, while we wouldn't have appreciated it, in the case of software, looks like we have achieved it. You have a platform and then you have upgrades all the time. So until the next big thing comes up, this upgrading goes on. Now please have a look at the monitor. You see here what looks like a very nice, cute product. Actually it is an enclosure. You can clearly see 3 distinct parts of it. We have a bottom case, we have a top case, we have a window, only out of sense of aesthetics I have put it, and then we have a gasket here. What is missing here is nothing is shown about what is inside and how is the whole thing held together. But as a student exercise, it made a lot of sense. So at this point, let me see whether there are any hidden objects, hidden layers. I don't see too much of it in this view. I will go back to the simple wireframe. Now you see here several things related to the construction lines. You see this, we have a plane here, and then we have a large number of these lines which represents how we wanted the product to be. So if I go here, and for purposes of clarity, I will see whether I can, I think this is good enough. See here on the right side, I think I probably have to switch off the background grid. We have here the profile view, then we have a plan view, and then some front or end view of these various objects that are there. How did we get here? I am just showing you the end result at this point. Now I will get out of this here, and then now try to get back to a series of I think several of you must have been using these boards. I do not know the generic name, but here it says Radio Shacks, some proto board or something. What you notice here is there are several small sockets. You can plug in your components, attach them together, and make first off a working concept. So the next slide will show you more and more of these similar things, except have you seen here a full circuit board itself is plugged inside. Some of them will go in automatically, some of them do not go, but just a few of the features I'd like to point out here is we have this output something, I will not use any word, some connectors here, and then you have a regulator here, then we have the power input here, and I expect here there are input and output pins that will make us access the particular this thing. So if you notice this, one of the first thing you will notice is it's all hardware. You have an on-off switch, then you have a crystal, probably there is a reset button, then you have some capacitors here, then you have some other type of connector and so on. And to make it work, okay, there are power supplies connected, and things are fed and so on. This is a little more with discrete components, except that you see here some of these components are more like hobby components, less of professional components, but the issue being that we can prove that our electrical or electronic component works. You have seen there, somebody has made a next level of thing. Oh, I do not know what exactly it means. I expect it's one ready-made PCB, except that outside, you have connectors here, and they are all connected here, and then you have a circuit that is running here. Well, at this level, it's very convenient, it's very good for us. It's not very practical for us to convert it into a product. And in fact, there will be provision for us, we can give in power supply. I do not know if it looks like a fan or anything. Now you see, in real life, the product seems to be packaged very well, and they're neat and clean, and I'm sure you have seen all of these things. Left side is what was conventionally a darkroom timer. except this is not a dark room, it is just a timer. Then you have the ubiquitous calculator. Now if you see this calculator, obviously one of the first things you'll notice is it has a beautiful display, and then because it's written something here, dual source, there is a solar panel, and then there are several types of keys of varying widths and all this. Next slide will now show you, if we were to take off the shelf components. So right side is a small collection of solar, I do not know, solar cells and soldered together and so on. And then you will notice that, I think I should put my hand there, no there, I don't, you see, they are all solar cells, they are all powered together, and then they can be connected to this small equipment. The equipment has small openings. I am not very sure what the openings are for. They look too close for switches, and I do not know what else is there for. But then what I would like to point out is this is a off the shelf small enclosure with an inclined panel. It is good, up to a point it is good. That was the panel in which these solar things could go, and then now we will notice is it's a little like Cinderella's shoes, doesn't fit that automatically as we want. But in real life, when you talk about displays and various other things, this is taken from the 3D machine from our fabrication shop. It's incidental as to what you read there. On the right side, you see that there are several types of keys. There is a display, and then keeping the practice of this, they have not touched what you call input output display panel. The next picture will show you. See, this is the left side of this thing. Right side is the one that normal operators are very much familiar with. You see in this Fanuc dial here, there is a, I do not know, it could be an inching dial or it could be a speed setting dial. Then you have various other things arranged in a simple logical way. Wherever it is possible, they have tried to maintain the ergonomics and familiarity which these things have with the other equipment that have been previously employed in the fabrication shop. This is taken from the horizontal lathe combination. Left side you have the actual controller, right side you have the something which, the left side you have the display, right side you have the controller, and the next slide will show you same thing arranged in a slightly different way. You see here, display is on top, the keys are down, and this keyboard and all are little similar to that, and then you see the other control panel. Nice, simple, beautiful panel. Some things are common, like how to operate and routine things. You have the jog dial, and then you have the feed rate, mode selector, then you have a key for editing the program, and then usual knobs, and then of course all of you must be familiar with the emergency stop. And then we have the various types of it could be anything, but in this case it could be actual cycling. Can you see this here? This is taken from our rapid prototyping, that water bath which will remove the support material. A little bit of elements of aesthetics and appropriate use has been built inside, but the common thing is you have a temperature indicator here, then you have something which probably runs the cycle and pump, and then you have several things about the water and so on like this. So what you notice here is the components are about similar. There is no problem with the components. But how we employ them and what we do with them, no, is still within our hands. That same control, this device has been now taken to a printer, a desktop printer. You see here, one of the first thing is, there nothing like all those what you call huge selection of buttons everywhere. It is just simple. There is one green button saying switch it on, and in case something jams, what you call probably reset it and do something, and then you will get your printout. This is taken from a probably a scanner, printer and combination. And then the critical thing is, you see the display, the angle of the display is a little similar to that same we had in the calculator, little about 15 degrees, because anything less than that, two issues are there. That angle of view of that screen is a narrow thing, and because of various constraints and various things, it cannot be very big. And it's a simple LCD screen, and the same screen, other than your normal routine things, is also used for your what do you say, diagnostics and various other prompts and so on. So the critical point in this, my next continuation of this today's thing will talk about where to start. So you'll see here, you see something here also, that is, you also have a mounting screw here. Why have they put it here? That is just to make sure that you don't damage something by pulling it out. This is from our same again our rapid prototyping setup, except this is a part of a laser, I do not know, I will loosely call it a plastic laser cutter. So you see here we have a beautiful display here. Again we have the emergency stop, and then there is some laser output and all that. You see here, this is also a control element and made specifically for the purpose. And then you again see, you watch this 15-degree angle, because it is very much related to the display part. I am sure all of you are familiar with these what do you call, equipment from your lab. Oh, I am not very sure what it is, but expect it is a power supply or a signal generator, and you have good. I am not able to read anything. Oh, it may be dual trace oscilloscope, you have something here and all that. Only things to note is, there is a little bit of similarity. I have seen that on the right side we have all the shrouded connectors, then we have rows of keys here, and then it seems to violate something which I told you earlier, saying if you have a key there, if you have a key here, you should have everything written on top, taken, correct. But then if you end up sometimes with something in the middle row here, it may lead to confusion, which is there where the designer's intuition and running a test with a target crowd. Usually it is not a focus group like what you do for soaps or cosmetics or kitchen utensils and all that. It is more of a professional group which analyze these things properly and see whether things are good or bad. So you see here we have something about something is written here at the bottom. Maybe in the beginning it's for you to locate, and eventually a lot of cautions are there, and then one only rather the redeeming feature in this is it is only used by trained professionals. Others are not expected to use it. Things have moved up. While that one is a sort of hardwired thing, you see that here now we have keys, and then there is a display. Probably the display will help you. It says LCR meter. Probably the display you can assign the keys. And then this is where I was telling you about the evaluation person would have said you can't afford to keep them so close. You need, this is the minimum gap between them. About that much has been maintained, and then you have a lot of space here. This is just an indication. You will see a similar indication like this in your ATM machines. There is a bit of parallax, of course, but then we have got used to it as such. We have no problem about it. And you see the beautiful LCR jack here, made of sheet metal. I am very, very proud to say this is supplied by the company and made out of sheet metal. You have a bottom view, then you have a top view, and then you see in a very simple way how they have done. They have put a screw here, given a, I think it's called a lugging. Advantage being, you can just open 2 screws, remove the cover, bottom of the cover comes off, turn it over, remove 2 screws, the top of it comes, and inside everything is visible. Probably it has some features which I don't understand, some, I think it's called a pad to reduce the voltage, or there may be feed throughs or some special circuitry. There may even be a board which conditions the signals, plus probably isolated and proof against ESD and so on and all that. So here you see a combination of it. This is probably made out of sheet metal. Then there is a handle which is made out of some flexible material. Then there is a molded cover, and then we are back again to sheet metal. In this case, probably it is inevitable because we have, see these connectors here. This looks like a BNC connector, then there are other variants of it. So these connectors require solid continuous earthing. So we have no choice but to use them. This is a very routine, what do you call, some multimeter. Unlike the other multimeters we have, this looks like a self-ranging digital multimeter. So you can select the usual DC volts, then you can have a DC amps. I'm not very clear about it how this hertz thing is there, and then there's a power button. This looks like something to do, no clue at all. Then there is small range between microamps and milliamps, and then you see here shrouded. Normally it's unlikely that you will get in touch with it. The important point is they have made a flat panel on top to make sure these things sit properly, and the actual device itself is a little fatter than what appears to be. Our eye only sees the outside lines. I will see, maybe we have come to the end of it. Yeah. Oh, it says some heating device and so on. These are all small laboratory scale things which have been made specially for our healthcare things here. So we have a capacity, then we have power, and then you see here, everything looks very, very simple and manageable. I have finished this part of it, so I will try to go down. Now we come to the important point is, where do we start? First thing is, like all other design approaches, you need to make out what is it that you want to make. So you identify a problem and then see several solutions and so on. And in the case of academia, what do? You check whether literature is already available. In the case of our product design, we check for existing practice or prior art. Prior art is in the trades, how do we do? Then something which is very related to this is whether it is already patented. If it is patented, it is somebody else's intellectual property, and generally patents may have run out, somebody may have released it, or so many other things are there. I am sure you have heard about the Sony Walkman, and then it uses cassettes called the compact cassette. Compact cassette was an IP held by Philips, and then they released it together jointly. Large number of these players as well as the cassettes were released to the public. So people could make cassettes and all, and then there also, no, you will notice that while a little bit of violation of this thing is there, it was an idea which went on very well. Old timers may remember stereo 8, what do you call, special type of cassettes which you put in cars. It's a very peculiarly, it's an endless cassette. It's big, and then later on we have DVD and all that. The issue being there, prior art decided on these things. So in our case also, first when we decide, we check what is it we want to do, check on all the prior art, and then start somewhere. As part of this, we may go and then, after having run a breadboard test and then decide on the standard modules. In this case, if you see typically, the displays are this 20 characters wide 2-line displays are typically seems to be what is used. And see at the bottom, most critical thing for us is this dimension, about that being about 120 mm. So this will come to 4.5 inches, and then 37, this will come to 1.5 inches. So we have a typically a display width of about this. Now if you go to the product specification page here and come to the end, I hope it's loading. Oh, I hope I have not missed it. Yeah, somewhere here details regarding the actual drawings will be presented here. It's in this, no? You have seen the confidential watermark on it saying you are not expected to use it in any of your designs unless you are using that particular component by them. So I respect it. That is how we have got into it. Thing you will notice is the PCB overall dimensions. I will try to enlarge it to see whether it comes here. You see here, it is given as 116 mm, and very critical thing is a tolerance also has been fitted on it. This is typically manufacturers what they contract with us, saying you cannot now go and you can say it is bigger than what we thought it would be. If you are mounting it by the holes, it is not a big issue, except that you need to again look at the same thing, 108 plus or minus 0.5 millimeters. So we need to make sure that under all conditions this fits. In this, the starting point, hence when I asked you, what do you think is the starting point, sir, is the component outlines. These need to be kept all the time. Okay? You have seen there. They have written saying it will not exceed 13.5 millimeters. And then typically from the front surface, the top surface of the printed circuit board is 9.3 millimeters. Now this will give you an idea of where to start the drawing you would like to save. In my case, I go about building these details. So in the case, you see what we need is, we need 4 openings. Typically it is written as 4 into 3.5 mm diameter holes. So it should give you a rough indication that something which is probably a metric 3 mm screw made at a pitch of horizontal pitch of 108 and vertical pitch of 29 mm we require. Understood? No, I start with 108 and 29. Now I go back here to my this place and see where actually I can start. I will start with a circle here. Oh. Diameter I start with see here my first this thing has started here. I started with a out of a convenience I started with a corner here. Now I see how best as I said, this is one way out of more of my practice. I have started practicing it. Now you see here, if you remember there in the previous thing, the horizontal hole were 108 mm apart, drawing some lines, and then you see this is typically, be a little patient with me, as I expect people among you who are good at these things are able to do them much faster. It will be much better than my just showing you something which is, you see there, this is the basic rectangle that 108 by 29 or is it 39 which I have selected here, and then I have an opening here. I will see if I can yeah. In there, those things which I started with, I have now copied them onto 4 places. Now the next level, I will go from here and see the overall size of the printed circuit board that is given here is, it is 116 by 37. So I just need to make this rectangle 116 by 37. I am from various what do you call earlier experiences, I have found out much better to work in a symmetrical point of view. So maybe I will just keep that other window open. So I have here 37, so half of 37 will be 18.5. Other side I have come earlier, if you remember, I had come up to 116. Again half of 116 is going to be 58 millimeters. I am a little slow, please be a little patient with it. See, now I have a printed circuit board here which is real, which has the 4 mounting holes, and then it has the outline, and then just to make things a little faster, we now need to come to the actual display area. So they have written here bezel is around 90 mm. In this case again bezel is 30 mm. So I will just see whether I will come to that 90 by 30 mm. So I will offset quickly. See, my basic display is ready now. See that my whole, one of the components in my design, the critical display I have now tried to create, which has all the necessary what do you call dimensions and all that. I will now try to actually group and freeze the whole device such that it stays with me all the time. Seen here. At this point I can even export this device. Understand, I take it and then as a backup this thing I export the selected thing to the desktop. To make things easier, I will just delete this slot. Now when I want to start the design of a, what do you call, my new design, one of the components, the critical component, the display is available with me. And if you remember last time, I also had a torch cell which I called cell and kept it on the desktop.